Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. In the last video, we created some simple sinusoidal models based on the context. Today, we will make the model a little bit more challenging. First, with a problem that involves a horizontal translation, and then the second problem, which requires a little bit more interpretation. So let's dive right in. For our first problem, we want to model the angle of a lighthouse beacon with respect to time. So just like what we did in the last video, before jumping straight into writing down the function, we want to first draw a diagram so that we can see what's happening. So we're going to have our vertical axis, and this is going to be our theta. And then we have our horizontal axis, which is going to be time. So now we're told that at time t is equal to 0, the beam is at the far right position of negative 30 degrees. So that tells us our starting point at t equals 0 is going to have a theta value of negative 30. So let's say that's right over there. So we're going to plot our first dot. Next, since we know that the minimum is at negative 30, and we also know that the maximum is at 210, we can use that to find our midline. So our midline is going to be equal to negative 30 plus 210 divided by 2. And that gives us a value of 90. So our midline is going to be at 90, which will be somewhere here. So that is our 90. And then our max is going to be at 210. So that'll be somewhere up here. So now, the fact that this light beam oscillates between negative 30 and 210 every 12 seconds tells us that a full cycle is going to be 12 seconds. So meaning our period here is going to be equal to 12. So let's go ahead and mark that down. So that would be 4, 8, and 12. So if we started at the lowest point at negative 30, at t equals 0, then that means one full cycle would happen in 12 seconds. So at t equals 12, we would be back at negative 30. And now we just need to go ahead and divide this interval up evenly. So halfway between 0 and 12 would be 6. And that is where we're going to reach our maximum. So that'll be 210. And then halfway between 0 and 6, we're going to be on the midline. And then halfway between 6 and 12, we're again going to be on the midline. So this is what our graph is going to look like. Now the difference between this problem and the problems from the previous video is that in previous problems, we had the freedom to choose whether we want to use a sine function or a cosine function, depending on the problem. However, for this problem, we were specifically told to write a sine function. So notice for this graph, it would actually be much simpler for us to use a cosine function because we're starting at the minimum, which means all we need to do is flip our original cosine function upside down. But because we have to write a sine function, we're going to have to deal with a phase shift here. So sine function starts at the midline, goes up to the maximum, comes back down to the midline, and then goes down to the minimum. So you can think of it as if we had our sine function and then we shifted it 3 units to the right. So which means instead of starting at t equals 0, that's why we're starting at t is equal to 3. So which means our phase shift, or p, is going to be equal to 3. So now let's go ahead and write down the important values. So we have our a, which is the amplitude. The amplitude is the difference between the midline and the max. So in this case, this would be 120. Our b value can be found using the period. So this is going to be equal to 2 pi divided by our period, which is 12. So this is equal to pi over 6. Our p value we've written up above, that is equal to 3. And then our q value, which is just the midline, that's going to be equal to 90. So therefore, our function theta of t is going to equal to 120 times sine of pi over 6 times t minus 3 plus 90. So this would be our answer to part A. For part B, we're asked to find the direction after t is equal to 4 seconds. So all we need to do is take our function and substitute in the value t is equal to 4. So we're looking for theta of 4. So this is going to be equal to 120 times sine of pi over 6 times 4 minus 3, which is just 1, plus 90. Now pi over 6 is one of those special angles. And we know that sine of pi over 6 is 1/2. So this would be 120 times 1/2 plus 90. So therefore, our answer to part B is 150. And then don't forget our units here, which would be degrees. For our next question, we're modeling the depth of water at a dock with respect to time. And this time, we're actually given the function. So part A, we just need to state the amplitude, the mean water depth, and the period of the tide. And we can actually get all that information straight from the function. So part A, we would have our amplitude. That is going to be equal to this number right over here, because 3 is our A value. The mean water depth, that is just the midline. So our midline is equal to 4. So the equation is just written in a different order, but you can think of it as this is 3 sine of this and then plus 4. And then finally, our period is going to be equal to 2 pi divided by our b value. And our b value here is pi over 6. So this means our period is equal to 12. Now for part B, we're asked to find what time of the day does the first high tide occur. So there's actually a couple ways to solve for that. Since we know that the midline is 4 and the amplitude is 3, we know that the maximum, which is going to be the high tide, is going to be equal to 7. So we can actually go ahead and solve the equation 7 is equal to 4 plus 3 times sine of pi over 6 times t minus 2. And we just look for the first t where this equation is true. But there's actually an easier way. We're going to consider our original sine graph. So recall that the original sine graph starts at the origin. It goes up to the maximum, comes back down to the midline, goes to the minimum, and then goes back to the midline. So the maximum occurs at pi over 2. Or in other words, it occurs 1/4 of the way through the period. So since for this particular function, our period is 12, 1/4 of the way is going to be 3. So let's go ahead and write that down first. So that's going to be 3. However, we also have a phase shift. So our phase shift here is 2. So if our p-value is 2, then that means we have now shifted the graph 2 units to the right. So which means instead of our sine graph starting on the origin, so let's go ahead and draw another one, we're now going to be shifted 2 units over to the right. So we would have our sine graph starting here, and then we have this shape. And since 1/4 of the way is 3 units, then that means the maximum is going to happen at 2 plus 3. So this is going to be 3 plus 2, which is equal to 5. So t is equal to 5. And now to answer the question, because they asked what time of the day. So t here is the number of hours after midnight. So if t is equal to 5, then that means this is going to be 5 a.m. Now part C, we're asked to sketch the graph for t between 0 and 24. So let's go ahead and draw our axes. So we have our vertical, which is the depth, and then we have our horizontal, and that is going to be our time t. Let's go ahead and say that each box is 2, so this will be 4, 6, 8, 10, 12, 16, 20, 24, 26, and 28. Our midline is at 4, so let's say 4 is here. And we're going to go and draw our midline. So since our phase shift is 2, that means we're going to start on the midline at t is equal to 2. And then our period here is 12. That means we're going to have one full cycle at 14. And then another full cycle ending at 26. And now our amplitude is 3. That means the maximum is going to be at 7, which is up here. And the minimum is going to happen at 1, which is down here. So let's go ahead and divide the intervals evenly. So we're going to be on the midline halfway in between. And that the maximum is going to happen halfway between 2 and 8. So that'll be at 5. So that's going to be our maximum. And then our minimum is going to happen halfway in between 8 and 14. So that'll be right down here. And then we're just going to repeat that for the second cycle. So it'll be right over here and right down here. So we're going to connect those dots in the shape of a sine wave. So then it should look something like this. And then the last part is that because we're asked to sketch the graph for t between 0 and 24, we need to add the missing part here. So we would have our minimum here, so we're just going to add a little bit there. And then we're going to go ahead and take our eraser and erase everything that is outside of the given domain. So this is what the graph would look like for t is between 0 and 24. And then finally, for part D, the harbor master wants to schedule maintenance whenever the depth of the water is less than 2 meters. So for what time intervals during the day can they do the maintenance? Now, if we look at this graph here, we can see 2 is right over here. So if we were to draw a horizontal line at d is equal to 2, we can see that the times that the tide is below 2 would be this segment over here, from here to here, and then from here to here. How do we actually solve for that? Well, what we're going to do is we're going to go ahead and find the intersection point. So we're going to find the t value here, 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 and here. And the equation to solve would be 2 is equal to 4 plus 3 sine of pi over 6 times t minus 2. Now moving the 4 over to the left side and dividing both sides by 3 is going to give us negative 2 over 3 is equal to sine of pi over 6 times t minus 2. So this here is not a special triangle, which means we're going to need to use our calculator to actually find the exact values. But before we do that, we're going to make this a little bit simpler. So we're going to do a substitution here where we let theta be equal to everything inside the sine function, so the argument. So our theta here is pi over 6 times t minus 2. Now, since t is in between 0 and 24, we're going to figure out what theta is in between. So theta is going to be in between. We're going to have pi over 6 times 0 minus 2. So that'll be negative pi over 3. And it'll be less than 24 minus 2 times pi over 6. So that is going to be 11 pi over 3. So that is going to be the domain that we're working with for our variable theta. Now, by doing this, we are solving for the equation negative 2 over 3 is equal to sine of theta. So we're going to take a quick look at what our domain is in terms of decimal points. So negative pi over 3 is roughly negative 1.05. And then 11 pi over 3 is roughly 11.52. So that gives us an idea of what numbers we're looking for. Next, we're going to go ahead and solve for the equation negative 2 over 3 is equal to sine theta. And like usual, we're going to ignore the negative sign and only treat it as a reference angle, and then we're going to use our ASTC rule to help us determine which quadrants we're in. So first of all, make sure your calculator is in radians mode. Next, we're going to do sine inverse of 2 over 3, and that is equal to 0.73. So we have our theta reference is roughly 0.73. So now using our ASTC rule, because sine is negative, we're going to be either in quadrant 3 or quadrant 4. And we have a reference angle of 0.73. So it'll be somewhere here and somewhere there. So this is 0.73 and this is 0.73. So now earlier, we said that our domain here goes from negative 1.05 to positive 11.52. So that means the first one is going to be the angle negative 0.73. That's going to be within our domain. And then the next one is going to be pi plus 0.73. So if we take our answer and we add pi, we get that is equal to 3.87. So let's go ahead and write those down. So we would have theta is equal to negative 0.73. Second one is 3.87. The third one is going to be 1 full rotation, which is 2 pi, minus 0.73. So we would have 2 pi minus this number here. And that would give us 5.55. So that would be our third number. Our fourth number is going to be 1 full rotation, which is 2 pi, plus 0.73. So that would be 3 pi plus this number up here. So let's go ahead and copy that. And we get that is 10.15. So that is 10.15. And then we're just going to check the next one as well. So the one after is going to be 4 pi minus 0.73. So 4 pi minus 0.73. And that is 11.83. But our domain ends at 11.52, which means this number is now outside of our domain, which means it's not part of our solution. So now we have these four numbers. However, these are in terms of theta, but we want them in terms of t. So what we're going to do is we're just going to substitute these numbers back into our equation here and find what the values are for t. And the way to do that would be if we were to solve for t in this equation, we would get theta times 6 over pi plus 2 is equal to t. So that means we're going to take these four values here and put them into this equation. So the first one is negative 0.73. We multiply this by 6 over pi, and then we add 2. Okay, so that gives us 0.606. And then our next value is 3.87. And make sure you take the full value and not the rounded value. So we multiply this by 6 over pi, and then we add 2. So that's going to be 9.39. The third one is this value here. So we take that, do the same thing. So times 6 divided by pi plus 2, which gives us this. And then finally, the last one is 10.15. So we're going to multiply by 6 divided by pi and then add 2. And that gives us 21.39. Okay, so I'm just going to move this away and then write those numbers down. And in fact, I'm actually going to write them on this graph here. So we have this value here, which is our first one. That one is 0.606. The second value is over here, which is 9.39. The third value is over here, which is 12.606. And then finally, the fourth value is right over here, which is 21.39. So now to finish it off for this part D, at what time intervals can the harbor master schedule the maintenance? That is going to happen when t is greater than or equal to 0, but less than 0.606. And they can do it when t is in between 9.39 and 12.606. And then the third interval is when t is greater than 21.39 and less than or equal to 24. So that would be our solution to part D. And now let's go ahead and do a quick recap of what we covered in this video. We saw how sinusoidal models can shift horizontally, and this represents a delay or a phase difference in real life. We saw what the amplitude means. It tells us how far the quantity swings above and below its average, which is the midline. The midline is also the center of the oscillation, or the long-term average. And the period tells us how long one full cycle is. And once a model is built, you can use it to evaluate, sketch, and solve inequalities. And now it is your turn to give this a try. Can you find the solution to this problem on the screen here? Make sure to leave your answer in the comments below, and let us know if you'd like to see more content on applications of trig in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.